Hello everyone, my name is Partho Das, Assistant Professor, JS College of Engineering, West Bengal, India. So welcome to my class. So today we are going to start a new subject, that is Basic Electrical Engineering, and in that Basic Electrical Engineering today in this particular class we are going to do the things that are related to your previous knowledge. So just this is a bash up class where we are going to do we're going to introduce the basic electrical engineering subject to you, and just brushing up the previous knowledge, school level knowledge that you have already. So those things we are just brushing up. Okay, so let us start. Let us see what are the topics, what are the things we are going to cover today. Then one by one we will start to solve, we start to discuss things together. Okay, so let us start. Yes, these are the objectives. After completion of this particular class, we are able to identify and implement theory of Ohm's law. Then we can define electrical terms. So resistance, capacitor, inductors, electricity, current, power. So there are different electrical terms are there. So within them, some terms we will try to understand today. And I think all of you, I think in school level physics, you have already done this. So so here also we are just brushing up those concepts over here. Okay, so number 3, to be able to describe the interrelationship between voltage, current and resistance in electrical circuit. The Ohm's law itself describes that relations, and there are other some relations, Ohm's law, then we have the KVL law, KCL law. So different laws are there, and in that case there are the different equations we can find out. So those are the things that we have to do. Okay, so let us see what are the next objective. To be able to identify digital multimeter features and its capabilities. Okay, so a multimeter is something which by using which we can measure many things. So it is basically a digital meter. Analog meter is also available, but nowadays digital meters are taking all over the market, and it has a standard price rate, and it can be used for the different purposes. So that's why it is taking the whole market. And to able to correctly use the digital multimeter, how to use the multimeter, that is a very important point actually. So how to measure the voltage, how to measure the current, maybe that is a DC voltage, DC current, or AC voltage, AC current, or resistance, or continuity, or and different things can be measured. Different things can be measured by multimeter. So we will see what are the things we can measure and how we can connect and how we can measure. So that those things we will do today. So these are the actually objectives we have in this particular class. So let us start. Okay, coming to the next slide. Yes, basics of electricity. So first of all we will see, so the electricity is it's an energy. So we know from the laws of conservation is that energy cannot be created, it cannot be destroyed. It's just change from one kind of energy to the other kind of energy. So let's first let us see that what are the different types of energies are available, and from which kind of energy we can convert that energy into the electrical energy. So first thing is that types of energy. What are the types of energy? Electrical energy, heat energy, atomic energy, mechanical energy. So heat energy can be converted into electrical energy, atomic energy can be converted into electrical energy, mechanical energy can be converted into electrical energy. So this is the process of energy conservation of our nature. Okay, and one form of energy can be converted into another. Yes, already told. Oil, heat, water, steam, turbine, mechanical energy, generator, electrical energy. So these are the actually elements or equipments from which we can get those kind of energy. That example is given. So for your understanding. So these are the types of energy we have. Okay. Now coming to the next slide. Yes. the source of this electricity. The source of this electricity is basically the it's basically hidden in the atomic structure of an atom. So in atom we have nucleus, we have in nucleus we have proton, we have neutrons, and there are the orbitals are there surrounding that nucleus, and in the orbital we have some electrons. Okay, so these electrons are negatively charged, and depending upon this number of free electrons, the electricity value, the capacity of an conductor made of some material which has some conductivity. So actually this conductivity is higher or lower, that depends upon the structural features of that material, because as the numbers of free electrons is increasing, so that then only the capacity of that wire can be increased. Okay, so as we can see in this particular diagram, so in the center we have a white circle and some blue circle. The blue circles are the protons, white circle are the neutrons. Proton basically it is positively charged, neutrons is chargeless, and this pink one is the electrons, which is negatively charged. Okay, so coming to the next slide. Yes, what is electricity? So let us see what is written over here. Three factors determines whether or not the atom is a good or bad conductor. So there are some factors depending upon which a conductor is chosen for any system, or a material can be chosen as a conductor. The number of electrons in the outer orbital. Yes, more numbers of electrons means it has more capacity. Less numbers of electrons in the outer orbital means it has less capacity. Okay, so this is point number one. The distance of the outer orbit from the nucleus of the atom. So that means if the distance, see in the below picture, just follow my pointer. So this black one is the nucleus. Okay, so and this one is the orbital, this one is the orbital also. So the distance between this nucleus and this electron is say x, and definitely this distance from this nucleus to this one is y. So definitely from the picture we can say that y is greater than x. That means this outer orbital distance from the nucleus is higher than the distance from the inner orbital electrons, correct? So when the distance is increasing, then from the attraction between proton and neutron is decreasing. Okay, so already in the previous slide I have told that protons are positively charged and electrons are negatively charged, so they are attracting each other. Now if the distance is increasing, then what will happen is attraction will going to be decreased, and if it is decreasing, then the possibility of increasing the number of free electrons will be increased. So if it is increasing, then it will be act as a good conductor, correct? So I think I am clear to my point. So number 3 point, the density of the atoms within the element. So say in an atom, in an element, the number of atom is very less. So if the number of atoms is very less, then what we can say? In the atom, because in the atom the number of electrons is then definitely less. So the conductivity of that material is decreasing. Now if it is happens that in the element we have a huge numbers of atoms, and each atoms contains some free electron, so it will give us high numbers of free electrons, so that means it is a good conductor. Okay, so that thing is written over here. So coming to the next slide. Yes, what is electricity? That thing we are discussing. Okay, so it is so two pictures we can see over here. So okay, in the center, um, if we if we just see the above picture, okay, so there are the huge numbers of electrons are in the different orbital, okay, and in the second picture, as you can see, there is a lesser number of electrons in the outer orbital or in the surroundings orbital, okay. So then let us see what is written over here. Carbon atom, sorry, which is a copper atom, good conductor, okay, 29 photons and 29 electrons, but only one loop electrons on the outer orbital. That means what? So this is a structural view of a copper atom where we have 29 electrons, but in the outer orbital we have only one electron. So if we give some supply, so if we give supply, the electrons will come out from the atomic structure of the copper atom, and the current will start flow. So this is the basic funda of any electricity flow. And if we come to the next diagram, the Dillon diagram, so there what we can say, this is a carbon atom actually. So in the carbon atom, as you can see, that the number of electrons is less. So if we give some sort of potential supply to that, then as the numbers of electrons are less, so the definitely less numbers of electrons will flow. And if the less numbers of electrons are flowing, that means definitely less current will flow. Okay, so depending upon the number of electrons, actually the electricity, the value of electricity depends. Okay, so coming to the next slide. Yes, this is nothing but the just pictorial representation of the electron and photons. Okay, and one more important thing, follow my point, in the last line, 1 coulomb. That means a huge amount of in an element, a huge numbers of atoms should be there, and if a huge numbers of atoms are there, then a huge there must be tendency of flowing of electrons. If a huge numbers of electrons are flowing, then that means it has a capacity to high current flow through it. So as you can see over there, 1 coulomb equals to the 6.25 into 10 to the power 10 electrons. So 1 coulomb means 6.25 into 10 to the power 10 electrons, numbers of electrons. So it is a huge amount of electrons. Okay. Okay, so this is another interesting and well demonstrated diagram. So what is there? What is there? So it is there that that is where in that where we have 2 electrons and 1 photon, correct? And it is connected to some sort of supply, that is a battery we have used. It has to, that battery has 2 terminals, positive and negative, follow my pointer, and there is a switch. This is a symbol of switch, okay, and it is showing us that is open, correct? Now and this whole system, the battery, the wire and the system is connected to some sort of load. Here we are considering a tungsten bulb. Okay, so coming to the next, when now we will see when the current when the switch is closed, how it is glowing. Yes, see in this particular diagram, what is there? The switch is closed. So if the switch is closed, then that means now it is a complete circuit. And now if it is a complete circuit, so what we can say that so this is the negative potential. So it will attract inside the conductor whatever positive ions are there, and this is the positive terminal, so it will attract whatever negative ions are there in the conductor. So as you can see over here, this are the electrons and these are the photons. So this negative will attract this photon, that's why it is direction in this direction, and the flow of this electrons will be this side because it is negative and this is positive, so it will attract each other. So all the electrons will try to come to the positive terminal and all the photons will try to come in the negative terminal. So as a result of that one, the current will flow from positive terminal to negative terminal, as we know that the direction of current is always in the opposite direction of the flow of the electrons. Okay, so this is a simple pictorial view how the current is flowing and why the current is flowing. Yes. So what is electricity? So there are a variety of methods of producing electricity. Yes, there are variety method. Okay. So through chemical reaction in a battery. So yes, we know that for large amount of electricity generation we use nuclear power plant, we use thermal power plant, we use one, and the main thing is that whatever power plant we are using there, actually we use some alternator, that is a synchronous generator, which are actually generates three-phase electrical supply, and that is distributed and transmitted distributed. So that's another thing. So point is that the electromagnet, that is known as the, if we rotate some machine, if we rotate some generator, and if from that if we use generate some electricity, then it is a electromagnetic action, definitely. So that points are mentioned over here. Through chemical process it can be done in battery, actually we do in battery, and for a large amount of electricity we use the generators. Okay, so that is the main funda of the cleaning generators is that electromagnetism. Okay, so coming to the next slide. Okay, so what is current? Current is a flow of electron. Conventional current is in the opposite direction of the electron flow. High voltage to low voltage, that means current always flow from higher potential to the lower potential. So you can say that current is always flow from plus to minus. Unit of current is ampere, we know. Current is measured by ammeter connected in series, polarity in DC. Okay, so these are the point, that means ammeter is used to measure the current through any element or device, and it is an ammeter should be connected always in series, so that how much current is flowing through that path we can measure that one. Okay, so now coming to the voltage. What is voltage? This is the potential difference between two terminal or two node. Okay, so unit of voltage is volt. Measured by how we measured by the voltmeter, and voltmeter should be connected in the parallel, so that it can identify what is the voltage drop across any terminal or branch, and that is shown in the voltmeter. Sources can be battery. The source of the voltage is battery. DC generator, alternator. So different things are there. One by one in the future class we will do these things. This voltage can be AC, can be DC. Yes. Polarity in the DC. Yes. Only polarity shows of voltage and current in the DC. But in AC we have polarity, but it is always changing. So we cannot mark or identify that this particular terminal is positive and that particular terminal is negative. No, we cannot do, because it is alternating. So once it is a positive, in the negative half it will be negative. Once one terminal is negative, in the next half it will be positive. So like this, so it is continuously changing. So you cannot mark there over there what is the polarity of that one. Equivalent to two water tanks connected by pipe water flows. Yes, very simple example. This is the voltage we have to apply to the system. So if we apply to the system, if we apply higher voltage to the system, higher current will flow. Now point is why if we give, instead of 10 voltage, if we give 20 voltage, we can find out that instead of 0.1 current it is flowing 0.2 current. Say for the example I am telling you. But why? Because of the electrical pressure. That means there is a huge attraction. When there is a huge attraction, when the attraction is increasing, so more numbers of electrons will be free from the atomic structure, and it will try to flow. And when the more numbers of electrons are flowing, that means more current is flowing. So that is the basic funda of that system. Now, what is resistance? So it is a very important thing. Resistance is basically it is the property of an element which opposes the flow of current. Okay. So now let us see what is the characteristics we have of in case of resistance. So opposes the flow of current. Yes, it's opposed. Unit of resistance is ohm. Already we know these things. So I'm just brushing off this thing. Measured by ohm meter connected across it. Yes, there is a ohm meter is available in the market by which you can measure the resistance of any conductor or whatever thing is there. Depends upon the material area and length. Yes, we know in school we have studied that resistance is equal to rho L by A, where rho is the resistivity, L is the length, A is the area. So these are the things depending upon which the resistance value or property may change, and we can calculate the resistance value if those components are known to us. Okay, produces heat when current flows through it. Yes, when current flowing through any particular resistor, there is a heat generation, there is a voltage drop, and due to that voltage there is a heat generation. Fixed and variable resistance. Yes, there are different types of resistance are available. It has some fixed value, some has variable value. Those are known as potentiometer, or it is sometimes known as the rheostat or pot. So different names are there in case of resistance. So let us come to the next slide. Okay, this is a very interesting picture is presented over here. Here, someone this person is representing the property of resistance, and this person is trying to find out how much current is flowing. So basic fund of the diagram is represented like this. There is a pipeline. So through pipeline we know current, water or oil may be flow. Now if we block that pipeline, so what will happen? There will be oppose in the flow of water or oil, and if we give higher oppose to the flow of water or oil, so there will be lesser amount of output from that system. So that concept, that man is just opposing the pipeline, so there is no electron flowing through the system, so there is no electricity in the system. So it is showing this picture is depicting the nature and behavior of a resistance. Okay. Yes. Now next thing is inductor. We know inductor generates some magnetic field. Okay. Inductor means some numbers of coil turn. Okay. So let us see what are the properties we have in case of inductor. So coil of wire opposes the charge in current used to create magnetic field for rotation. Unit is Henry. Open and short inductor. Okay. So this inductor has some property. What are the property this inductor has? The inductor has we can say that inductor has two functions to do. So one function is it can generate electricity. It can generate some magnetic field, and once it is generated some magnetic field, it's try to oppose the change of any current value through it. Okay, these are the main two property of an inductor has. Okay, so it opposes the change in electricity passing through it. Okay, so those things are mentioned over here. So unit is Henry, and after that means change, it opposes the change of electricity, means it again like it is acting as resistance. That means current is trying to change, current is trying to flow, it is opposing that one. So it has some reactance property also, that is known as the inductive reactance denoted by XL. So in the future class we will going to deal with those components. So for now it is enough for you. Okay, now the capacitor. So let us see what are the properties we have with this capacitor. Two metal plates separated by a dielectric material and which can store some energy. It is a capacitor, we know. So gets charged when voltage is applied. So when supply is given, so two plates are there. The two plates are polarized, and due to that there is a storage of energy. Okay, and what is the unit of capacitance? It is a farad. Okay, so now we know the resistance series parallel combination in school level we have very well understood that one. If resistance are connected in series, they are directly added. If they are in parallel connection, there is a inverse relation in between them. So in case of capacitor, we can say that whatever is the series parallel combination in case of resistance, and here in case of capacitor, the property, the mathematical expression is totally opposite. That means if two resistance, two capacitance C1 and C2 are in parallel, then they are directly added. C1 plus C2 is the total capacitance value. And if two capacitance are in series, then they are inversely added. As you can follow my pointer, as we can see in this particular diagram, 1 by C is equal to 1 by C1 plus 1 by C2. So it is inverse case, and when they are parallel, C is equal to C1 plus C2. So this is very easy to understand. So whatever case is there in case of resistance, and in case of capacitor, the case is totally reversed. So coming to the next, okay, insulators and conductors, very interesting point. So again, coming to the basic funda, what was our basic funda? Our basic funda was that there is a element. In element we have atomic structures. In atomic structure we have a huge numbers of, we have not huge, we have some electrons. And now when we know that when the numbers of electrons is increasing, at that time through that one high current can flow. So if the bonding between nucleus and the electrons, if it is very high, the bonding between nucleus and electron is very high, okay, and due to that no electrons can coming out from that orbital. So if it is happen, then a lesser current or no current can flow through that particular element, and if it is happening, then it is known as the insulator, through which a very less amount of current, or not very less amount, but actually no current is flowing through that insulator. So if some current is flowing, then it is a conductor actually. So insulator means it has some property that it has no free electrons, and its nucleus and electron bonding is such a high level, so that no free electrons, no electrons can come out from the system, so that no current can flow through it. So it is the property of insulator. And reverse case is for the conductor. So in case of conductor, we need more free electrons. So we have to choose such an element which has a higher number of free electrons, which has very weak bonding between nucleus and electrons, so that if we supply very few volt to the system, or very few potential to the system, and then also the electron can come out from the orbital, and current can flow through this one. Okay, so these are the property of insulator and conductors. This is Ohm's law. So we know that considering the temperature and pressure constant, the current flowing through a particular conductor is directly proportional to the potential difference of that particular conductor and of any two particular point within this particular point. So rho V various I, and when we are eliminating this equivalent sign, then there is a V is equal to IR. So I am not going to in that details, because we have already several times we have seen it, and we have solved different problems in our school level. So just remembering these things. So this is Ohm's law, just pictorial representation for you. It is very interesting to see. Okay, coming to the next, DC power. So DC power means a power formula is given by voltage is V, is denoted, I is denoted by I, and so power will be V into I. Now again, from the concept of Ohm's law, we can put that. So follow my pointer. So power in DC circuit is P is equal to V into I, where V is again I into R from the Ohm's law. So I square R is another power formula. So actually V into I is a apparent power formula. Okay, and I square is the loss current formula. So there is different power formulas are there. So not we are not going for that details. So we will discuss in the future classes. Okay, and unit of mechanical power is horsepower, and 1 horsepower means we know that 746 watts. Okay, so there are some small problems are given over here. So so application of power formula, not going to for details, not going for the details. This is very simple. Just check yourself. Okay, now AC power. So let us see what are the properties we have in case of AC power. Alternating quantity is one which periodically passes through a definite cycle of changes. In AC RMS values are used. So whatever. So see, suppose say there is a system and there is a closed loop and some current is flowing, and you are using some meter to measure that current. Now whatever reading you can see in the meter, that those are actually the RMS value. Okay, so that means whatever mathematical problem we will do and whatever solution we want to find out, those are all RMS values. Okay, so AC power is consumed by different types of load such as inductive, resistive and capacitive. Yes, AC power can be consumed by different element, different types of load. R, L, C all can be consumed. But in case of DC, it doesn't have inductance and capacitance because they cannot work with DC source. So in that case, only resistance is working. Okay, so this AC power is given by V into I into cos phi, where this cos phi is the power factor. Okay, so what are does the AC component measured by wattmeter, power is measured by wattmeter, we know. So the unit of the power is watt, yes we know. So not going to details, coming to the next. Yes, this is a very interesting picture of a chart where we can see that what is the current abbreviation, unit, symbol, measuring tool. So everything is mentioned over here. So whatever till now we have discussed, that summary is presented over here. So very interestingly, you have to remember those things, because in future you need those things daily. So we have to remember, and then we have to understand this thing. So coming to the next slide. Okay, so what is series circuit? So series circuit means one path for current flow can have more than one load. Yes, it is possible. The load is sum of individual loads. Yes, some voltages loss takes place across each. That means suppose say in a series loop a source is there, and with that 2-3 resistance are there, all unconnected in series. When due to this closed loop some current will flow, when some current is flowing through that particular series loop, so due to the presence of voltage, from the Ohm concept of Ohm's law, you can say that V is equal to IR. So across each resistance there are some voltage drop, correct? So that thing is mentioned over here. Okay, sum of the voltage drop across each load is equal to the applied voltage. Current through each load is same. Yes, because a single current is flowing through this one. Open and short circuit example. Okay, chain of small bulbs, there is the example of series circuit. Yes, now coming to digital multimeter description. It is a very important device for different colleges, different experiments, and the household also. The household person also sometimes carry, or they bring a digital multimeter for checking the lines, or many purposes they actually use. Okay, so measure using multimeter we can measure many things. Okay, so AC DC voltage current, so long thing maybe we can measure. So let us just pictorially see how we can measure those things. Yes, so these are the things we can measure. So see, so follow my pointer. This is AC voltage we can measure, DC voltage we can measure, EV voltage we can measure, resistance we can measure, diode test we can do from this one. Then AC current we can measure, DC current we can measure. Okay, another thing is there that is continuity check. So there is a buzzer knob where you can set the multimeter, and if we just make the connection in between two terminals of that one, it will showing as a buzzer. It is used for the checking of the continuity. If there is any break of any conductor, if we connect the two terminals of that one, and if the buzzer is blowing, then that means the wire is correct. If the buzzer is not blowing, the wire inside that where some problem is there, okay. So for that purposes, the digital multimeter can be used. Okay, voltage measurement. This is a DC voltage measurement, ranges up to 10 to 10,000 volts, and in case of AC, that voltage is sorry, not for the AC, not 10,000, 1,000, 0 to 1,000 volt, and in case of AC, 0 to 750 volt. We can measure. Yes, resistance 320 ohm to 32 mega ohm. Up to that we can measure. Current measurement 320 milliamperes to 10 amperes we can measurement in case of AC. In case of DC, 320 milliampere to 10 ampere in DC we can measure. So in this current case, the ranges are same. Okay, so diode test, 2 volt DC continuity test. So it is the continuity test. If it is the diode, it is the buzzer is blowing, then it is the diode is correct. Okay. Okay. So this is electrical circuit representation. So there is a battery, there is a ammeter to measure the current, there is a motor which is across which the voltage drops are occurring. So this is just a pictorial representation of any kind of simplest circuit. Okay. So now we will see that what are the different types of loads are available. So there are different types of loads are available: resistive load, inductive load, and capacitive load. So we know the nature of resistance, inductance, and capacitance. So the nature of resistive load, inductive load, so and capacitive load, those things are there. So one by one we will see what are the characteristics it has. So resistive load in DC circuit, the voltage and current waveforms are straight lines because voltage is constant. Very simple. Already we have discussed in the school level physics. In AC circuit with pure resistance, voltage and current are always in phase. Yes, there is no lead lag concept in case of DC. Power consumed in DC circuit is constant as voltage and currents are constant. Very good point. So it is obviously, and AC circuit that has only resistance produces a positive power curve. So these are the property for our resistive load. Another property in DC circuit, the voltage and current waveform are straight lines because it is a constant. Okay, that is already done. Inductive load, and inductor is a coil of wire. A common inductive load is an electrical motor. Yes, very good, because in motor we have thousands of winding, and that act as a huge inductor. Current lag behind voltage by a 90 degree. Yes, it is a lagging circuit. In lagging circuit we know from voltage current is lags by an angle 90 degree. Produce both positive and negative power as it is a AC quantity, sinusoidal quantity. These powers are equal in magnitude, but their sum will equal to 0. Okay. The inductor does not use real power. Still, the generator supply is it is voltage and current, so efficiency is lower. So these are the property. Now coming to the capacitor load. A capacitor opposes charge in voltage. Yes. Current lead. In this case, its current is leading by 90 degree from the voltage level. It can produce both positive and negative. Yes. Capacitor does not use real power. Still, generator supply it with voltage and current. Okay, the efficiency is also lowered over here. So these are the things we want to cover today. So I think you are now able to understand what is electricity, how electricity is generated, what the different types of load are there, how the connections are made. what is multimeter, what is the purpose of using multimeter. By using multimeter, what we can measure DC AC voltage, current. So what those things we are now able to understand. Okay, this is all for today. Thank you.